Imagine a world unlike any you have ever known, a world of profound silence, broken only by the faint rhythmic pulse of life itself. This is the deep ocean. It is a realm of eternal darkness, where the sun's rays can no longer penetrate the immense weight of the water above. As one descends, the familiar blues and greens of the surface world give way to an endless, inky blackness. It is a place that feels utterly vast and empty. Yet this impression, as we shall see, is wonderfully misleading. The pressure here is immense, a crushing force that would instantly destroy any unprotected human body. Yet life has found a way not just to survive, but to flourish in the most extraordinary ways. The feeling of being in the deep sea, even within the safety of a submersible, is one of both profound isolation and immense wonder. Outside the small porthole, there is nothing but darkness, a void that seems to stretch on forever in every direction. It is a humbling experience, a reminder of how small we are in the face of our planet's immense hidden landscapes. This is not the bustling, colorful world of a coral reef. It is a place of quiet contemplation, where time itself seems to slow down. The sheer scale of it is almost impossible for the human mind to grasp, a hidden kingdom that covers more than half of our planet's surface, yet remains almost entirely unknown to us. This great dark expanse was long thought to be a place devoid of life, a sterile desert under the sea. The conditions are, after all, extreme. The cold is biting, often hovering just above freezing. There is no sunlight to power photosynthesis, the very foundation of most life as we know it on the land and in the shallow seas. And of course, the pressure is staggering, increasing with every meter of descent. It is a world that seems hostile to life in every conceivable way. And yet, this is precisely what makes the deep ocean so utterly captivating. It challenges our very understanding of what it means to be alive and where life can thrive. The mystery of the deep is perhaps its greatest allure. What secrets does it hold? What strange and wonderful creatures drift through its silent, dark waters? For centuries, this was a realm of pure speculation, a place for sea monsters and legends. Today, thanks to remarkable advances in technology, we are finally beginning to pull back the curtain on this enigmatic world. We are discovering that far from being empty, the deep ocean is teeming with life. It is a world of shimmering lights, ghostly forms, and ingenious survival strategies. It is a journey into the unknown, and it is a journey that reveals as much about our own planet as it does about the creatures that call this abyss home. For much of human history, the deep ocean was a subject of folklore and fear, not scientific inquiry. It was simply too remote, too inaccessible. In the mid-19th century, as the science of marine biology began to take shape, one prominent theory took hold. The respected naturalist Edward Forbes, after dredging the Aegean Sea, proposed what became known as the Azoica, or abyssus theory. He observed that as he sampled deeper and deeper, the abundance and diversity of life seemed to diminish. From this, he extrapolated that below a certain depth, around 550 meters, life would simply cease to exist. The conditions, he argued, were just too extreme for any organism to survive. Forbes's theory was logical and based on the best evidence available at the time. The deep sea, with its crushing pressure, perpetual darkness, and frigid temperatures, seemed an impossible habitat. For a time, the scientific community largely accepted this idea of a lifeless abyss. It painted a picture of our planet with a vibrant living surface and a vast sterile core in its deep waters. This notion of a dead zone at the bottom of the sea persisted for several decades, shaping our understanding of the planet's oceans and the limits of life itself. It was a simple, tidy explanation for a world that was beyond our reach. However, Hints that forbs might have been mistaken began to emerge. Telegraph cables laid across the Atlantic Ocean floor in the 1860s would occasionally be brought to the surface for repairs. Astonishingly, these cables, which rested at depths far below Forbes's proposed limit, were often encrusted with marine organisms. There were corals, mollusks, and other invertebrates, creatures that had clearly grown and thrived in the supposed Azoic zone. These discoveries were a direct contradiction to the prevailing scientific consensus. They provided the first tangible proof that life was indeed possible in the crushing blackness of the deep sea. The abyss was not dead, after all. This revelation sparked a new era of deep-sea exploration. The famous Challenger expedition from 1872 to 1876 was a landmark voyage that systematically explored the world's oceans, including their deepest trenches. Its scientists dredged the seafloor at incredible depths, bringing up a stunning variety of previously unknown species. The evidence was undeniable. The abyssus theory was wrong. The deep ocean, far from being a lifeless void, was a habitat for a remarkable and diverse array of creatures. This paradigm shift opened up a whole new frontier for biology, revealing that the largest habitat on Earth was not empty, but was instead a treasure trove of life waiting to be discovered. The ocean is not one single environment, but a series of stacked worlds, each with its own distinct characteristics and inhabitants. Scientists divide the water column into vertical zones, much like the different altitudes on a mountain. The journey downwards is a journey of dramatic change. It all begins at the surface, in the epipelagic zone, or the sunlight zone. This is the ocean we know best. It extends down to about 200 meters, the maximum depth that sunlight can penetrate. This is a world powered by the sun. Here, countless microscopic plants called phytoplankton use photosynthesis to create energy, forming the base of a vast and complex food web. This sunlit world is a place of vibrant activity. It is home to the great schools of tuna and mackerel, the majestic whales and dolphins, and the sprawling beauty of coral reefs. The abundance of light and food supports a staggering amount of life. It is here that the ocean breathes, with phytoplankton producing a huge proportion of the Earth's oxygen. Everything in this zone, from the smallest shrimp to the largest shark, is directly or indirectly dependent on the energy of the sun. But as we leave this bright, bustling world behind and begin our descent, the rules of life begin to change profoundly and irrevocably. Below the sunlight zone lies the mesopelagic zone, more commonly known as the Twilight Zone. It stretches from 200 meters down to about 1,000 meters. Here, the sunlight fades rapidly. The light that does reach these depths is faint and ethereal, a perpetual blue dusk. It is not enough to support photosynthesis, so there are no plants here. This marks a fundamental shift in the ecosystem. Life in the Twilight Zone must rely on food drifting down from the sunlit world above, or on hunting other creatures that share this dim, mysterious realm. The pressure increases and the temperature drops significantly. Beyond 1,000 meters, we enter a world of complete and utter darkness. This is the bathypelagic zone, or the midnight zone, which continues down to about 4,000 meters. No sunlight at all reaches these depths. It is a world of unimaginable pressure and near-freezing temperatures. Below that is the abyssopelagic zone, the abyss, and even deeper, the hadopelagic zone in the ocean's deepest trenches. These lower zones were once thought to be barren, but we now know They contain remarkable oases of life, such as hydrothermal vents and cold seeps. Here, life is not powered by the sun, but by chemical energy seeping from the Earth's crust, a process known as chemosynthesis. This vertical journey through the ocean's zones reveals a planet of incredible diversity, with different rules for survival at every level. The Twilight Zone, or the Mesopelagic, is a world of transition and adaptation. Sandwiched between the bright world above and the total blackness below, its inhabitants have evolved some of the most ingenious strategies for survival on our planet. With no plants to form the base of the food web, life here is largely dependent on what falls from above. This constant gentle rain of organic matter is known as marine snow. It consists of dead phytoplankton, remnants of zooplankton, fecal pellets, and other miscellaneous debris from the productive sunlit waters. To the creatures of the Twilight Zone, this marine snow is a vital source of food, a life-sustaining blizzard in the dark. Many animals in the Twilight Zone have developed large, highly sensitive eyes to make the most of the faint, dwindling light. These eyes are often tubular and pointed upwards, perfectly designed to spot the silhouettes of prey or predators against the dim glow from the surface. Creatures like the hatchetfish have incredibly slender bodies, making them almost invisible from below, while their large, upward-gazing eyes search for their next meal. Bioluminescence, the ability for an organism to produce its own light, also becomes increasingly common here. It is used for communication, for luring prey, and for defense, creating dazzling light shows in the perpetual dusk. One of the most significant events in the ocean is the vertical migration. Every single day, as the sun sets, countless creatures embark on the largest migration on Earth. Trillions of small fish, shrimp and squid swim hundreds of meters up from the Twilight Zone to the surface waters to feed under the cover of darkness. They feast on the abundant phytoplankton and small zooplankton in the sunlit zone. Then, as dawn approaches, they descend back into the relative safety of the deep, dark water to avoid being seen and eaten by daytime predators at the surface. This daily journey is a critical process, transporting enormous amounts of nutrients from the surface into the deep ocean. This constant movement connects the upper and lower zones of the ocean in a profound way. It is a vital link in the marine food web and a key part of the planet's biological pump, which helps to regulate our climate by sequestering carbon in the deep sea. The animals that perform this migration are a living conveyor belt, actively carrying energy from the sunlit world down into the abyss. The Twilight Zone is therefore not just a passive recipient of marine snow, it is an active participant in the ocean's great cycles. Its inhabitants link the surface and the deep, playing a crucial role in the health of the entire marine ecosystem. Deeper still, below the Twilight Zone, lies the vast expanse of the midwater, the bathypelagic or midnight zone. This is a world without sun, a realm of crushing pressure and relentless cold. Here, life is sparse compared to the bustling zones above, and the creatures that live here are among the most peculiar and fascinating on our planet. They have evolved to thrive in an environment that offers very little food and, well, no place to hide. Many are gelatinous, with bodies composed almost entirely of water. This buoyancy is a great advantage, as it requires very little energy to stay afloat in the water column. Creatures like gossamer worms and many types of comb jellies drift effortlessly through the darkness. These gelatinous animals are masters of energy conservation. A gossamer worm, for instance, is a delicate, transparent creature that swims with mesmerizing ribbon-like movements. Being mostly water, it doesn't need a heavy skeleton or dense muscles. The same is true for the countless species of comb jellies or ctenophores. They are not true jellyfish but are beautiful, fragile predators that capture tiny prey with sticky tentacles. Many of them are bioluminescent, producing shimmering, rainbow-like displays of light that ripple along their bodies as they move. In the total blackness of the midwater, these living lights create a truly magical and surreal spectacle. One of the most remarkable groups of animals found here are the siphonophores. While they may look like a single jellyfish-like organism, each one is actually a colony of many individual, specialized animals all working together. Some individuals are responsible for swimming, others for feeding, and others for reproduction, all linked together in a long string-like chain that can sometimes stretch for many meters. They are formidable predators, trailing a curtain of stinging tentacles to ensnare any unsuspecting fish or crustacean that blunders into them. Some species, like the Praia dubia, can grow longer than a blue whale, making them one of the longest animals in the world. Even creatures we might consider more conventional have strange adaptations here. The deep-sea snail, for example, has a shell so thin it is almost transparent, and it develops a wing from its foot to help it fly through the water. The anglerfish is perhaps the most famous resident of the Midnight Zone, with its iconic bioluminescent lure that it dangles in front of its mouth to attract prey in the dark. Life in the midwater is a testament to the power of evolution. In this vast, dark, and seemingly empty space, life has found a way, producing forms that are beautiful, bizarre, and perfectly suited to a world without light. For most of history, the deep ocean was beyond our grasp, a place of imagination. Today, that has changed. We are living in a golden age of deep-sea exploration, thanks to organizations like the Schmidt Ocean Institute. Founded by Eric and Wendy Schmidt, the Institute operates a state-of-the-art research vessel, the Falcor 2, which is a floating laboratory dedicated to exploring the world's oceans. This ship provides a platform for scientists from around the globe to conduct groundbreaking research, giving us an unprecedented window into the mysteries of the deep. It is from this vessel that the real explorers of the deep are launched. These modern explorers are not people, but robots. Remotely operated vehicles, or ROVs, are sophisticated underwater robots that are tethered to the ship by a long cable. The ROV Sebastian, for example, is equipped with powerful lights, high-definition cameras, and robotic arms for collecting samples. It can descend to depths of 4,500 meters, allowing scientists on the ship to fly through deep-sea canyons and over underwater mountains in real time. They see what the robot sees, broadcast live on screens in the control room. It is a form of telepresence, allowing human eyes to witness a world that is far too hostile for a person to visit directly. The discoveries made using these robotic explorers are nothing short of revolutionary. On expeditions, scientists have discovered dozens of new species, from otherworldly gelatinous creatures to strange new types of coral that thrive in total darkness. They have mapped vast, previously unknown underwater landscapes, including towering seamounts that are hotspots for biodiversity. They have explored hydrothermal vent fields, where superheated, mineral-rich water erupts from the seafloor, supporting entire ecosystems that are completely independent of the sun. These robots are our eyes, our hands, and our sensors in the deep, bringing back data and images that are transforming our understanding of the planet. The Schmidt Ocean Institute is committed to sharing this journey of discovery with the world. The high-definition video feeds from the ROV's dives are often streamed live online, allowing anyone with an internet connection to join the exploration in real time. This open approach to science helps to foster a sense of wonder and connection to this remote part of our planet. It reminds us that there are still vast unexplored frontiers right here on Earth. Through the work of the Falcor 2 and its robotic companion Sebastian, we are steadily illuminating the darkness and revealing the deep ocean to be a place not of emptiness but of incredible wonder and life. It is easy to think of the deep sea as a separate, isolated world, a place disconnected from our own, but this could not be further from the truth. The entire ocean, from the sunlit surface to the darkest trench, is a single interconnected system. The life of the deep is fundamentally linked to the life at the surface, and both are essential to the health of our planet. The great engine of this connection is the biological pump. As phytoplankton at the surface die or are eaten by zooplankton, the carbon they contain begins to sink. This is the origin of marine snow, the foundation of the deep-sea food web. This downward flow of nutrients is the lifeblood of the deep. Without it, the twilight and midnight zones would be far more barren. But the connection is not just a one-way street. The daily vertical migration of trillions of animals from the deep to the surface and back again is a massive, active transport system. These creatures bring nutrients back up with them, and their own bodies become food for predators in different zones. Furthermore, the life cycles of many animals connect different depths. For instance, some jellyfish may spend part of their lives as tiny planktonic polyps on the seafloor before growing into the familiar drifting forms we see higher in the water column. Even creatures that seem confined to one zone can have a far-reaching impact. The planktonic stage is a crucial part of the life cycle for a vast number of marine animals, not just jellyfish. Many fish, crabs, and even starfish begin their lives as tiny larvae, drifting as plankton in the water column. Their distribution depends entirely on the currents. Some may stay near the surface, while others are transported to different depths. This means that a population of crabs on a seamount in the deep sea might be reliant on larvae that drifted from hundreds of miles away. This intricate web of life, connected by currents and life cycles, makes the entire ocean a single dynamic habitat. This interconnectedness highlights the vulnerability of the deep ocean. What happens at the surface directly affects the deep. Pollution, overfishing, and the warming of the surface waters all have consequences for the creatures living thousands of meters below. Changes in the phytoplankton populations at the surface can alter the amount of marine snow, effectively causing a famine in the abyss. Understanding these connections is vital. The deep ocean is not a remote wasteland that we can afford to ignore. It is an integral part of the planetary system that supports all life, including our own. We stand at a critical moment in our relationship with the ocean. While our technology allows us to explore its depths as never before, that same technology has also given us the power to harm it on an unprecedented scale. Deep-sea mining, bottom trawling fishing, and plastic pollution threaten to damage these ancient, fragile ecosystems before we have even had a chance to understand them. This makes the mission to explore the deep ocean more urgent than ever. We simply cannot protect what we do not know. Exploration is the first and most vital step towards conservation. By studying the deep ocean, we learn about the fundamental principles of life itself. How can creatures survive under such immense pressure? How can entire ecosystems thrive without sunlight? The answers to these questions expand our understanding of biology and could lead to breakthroughs in medicine, materials science, and biotechnology. The unique chemical compounds found in deep-sea organisms, for instance, may hold the key to new medicines. The bioluminescent systems of deep-sea creatures could inspire new forms of lighting technology. The deep sea is a library of biological innovation that has been evolving for millions of years. Exploring the deep sea also helps us to understand our planet as a whole. The ocean plays a critical role in regulating the Earth's climate. It absorbs vast amounts of heat and carbon dioxide from the atmosphere, much of which is eventually sequestered in the deep sea. By studying the processes of the deep ocean, such as the biological pump and ocean currents, scientists can build more accurate models of our climate system. This knowledge is essential for predicting the future impacts of climate change and for developing strategies to mitigate them. The health of the deep ocean is inextricably linked to the health of the entire planet. Ultimately, we explore the deep ocean for the same reason we climb mountains or gaze at the stars, for the sheer wonder of discovery. It is a fundamental part of our human nature to want to know what lies beyond the horizon, or in this case, beneath the waves. The deep ocean is the largest and least known frontier left on our own planet. Each dive with an ROV brings the potential for a new discovery that could rewrite our textbooks. It reminds us that our world is more complex, more beautiful, and more mysterious than we can imagine. To turn our backs on this world would be to lose a vital part of what it means to be a curious species on a remarkable living planet.